had been studying distributed systems and file systems and so on in the past, I had like a bunch of ideas that had been simmering in my mind for many years. And kind of like around 2013, I put a set of these together into what became IPFS.
IPFS stands for
the Interplanetary File System, which is it's an homage to the internet, because the internet actually stands for the Intergalactic Network. That's like the real name.
I did not know that.
It comes from a memo from Licklider, like early on, who's like one of the main people that helped, organize all the resources to do the development of the internet in the early stages. And, because so at the time there were all these different networks that were all kind of piecemeal and so on. And like, you couldn't like interconnect things. And so he's like, this is ridiculous. We just need everything to talk to each other. Like, we need one meta network, one like network of networks. And if we build it right, then it could extend into like the planets and the stars and like eventually be like one network for the whole galaxy. And like the early memo like just talks about like the intergalactic network. And that's the internet. It's like the birth of the internet. Like it's way earlier than the web, way earlier than TCP/IP. This is like the stuff that put everything in motion to cause those things to happen.
So in that context, interplanetary file system is really a small vision, right? It's not
exactly.
even intergalactic. Yeah,
exactly. I was like, like if we're going to build the intergalactic network, at least let's get the planet stuff working right. And then eventually we can figure out like the interstellar level. Yeah, totally.
Welcome back to the Slow Hunch. This week, I'm thrilled to welcome Juan Benet, the founder of Protocol Labs, to the show. I've had the pleasure of knowing and working with Juan for about a dozen years now, back to when we at USV participated in the seed financing of Protocol Labs, which led to projects like Filecoin and a bunch of others. Juan is one of the most interesting deep thinkers about what's possible on the internet. Peer-to-peer systems, decentralized protocols, governance, and looking towards the future, really how to think about funding and sustaining the critical infrastructure that we use every day, digital and otherwise. And so I hope you enjoy the conversation with Juan. We've known each other for 12 years now. I was just looking back at the original like email history and it goes way back. I'll never forget the day that you showed up at USV in 2014 and you put up a chart on the screen showing the Bitcoin hash rate. And you said something along the lines of, you see what's happening here? We're harnessing all the world's computers to do useful work. Like we can take this in a lot of different directions. And it was inspiring. And so anyway, I that's like etched in my memory. So happy to talk today about your story, where you came from and where you're going.
Yeah, thanks for having me. Super excited to be here. And likewise, it's been awesome to work together for 12 years. Like, time flies. And one of the things that like I've always admired is just how methodical and thoughtful you are about thinking about markets and thinking about different pieces of technology and how they might develop. I mean, this is true about all of USV, right? Like, it's one of the really special things about the firm.
Yeah, and I think of USV as kind of a slow hunch in general, but what I like about the idea of the slow hunch is that you don't necessarily have to have the whole answer at any given point in time. It's just about like continuing to turn cards, right? And having like an intuition or an inclination that something big is possible. And then to me, the most interesting thing is like, the actual story of what happens when you open this door and then the next door and then the next door. So maybe just to set the table for everybody, it might make sense for you to just introduce yourself. Who are you? What have you been working on? And how might you characterize the kind of slow hunch that you've been following?
Great question. So my name is Juan Benet, and I'll give like a short bio just because I think it might be useful context. So I was born in Mexico and I grew up there. I moved to San Diego when I was 15 or so, and then went to college in the Bay Area at Stanford. I started networks and distributed systems, and I also like had a kind of like life in theater and different arts, and so I kind of got exposed to a lot of different perspectives, and maybe more than any place, the internet really shaped me. So I kind
Hmm.
of got to the internet early, like when I was 13, 14, through video games actually. So I used to play a lot of video games,
Yep.
and that the culture of the internet really shaped me in a huge way. Kind of like this idea that you would have like this magical device in your house that could like connect you to the rest of the world, and that was just super special. And just it opened this curiosity for me of trying to understand how these systems connected, how they message each other, how is it that like a video call would work. I was super inspired by Skype. Like I remember
Sure.
seeing the transformation that Skype did, enabling people to now go from like long distance, super expensive calls to now being able to like, families connecting and talking for hours, and just like really brought the world closer in a huge, huge way. And and then in kind of in college, I studied because I studied networks. I revisited Skype in now in the context of trying to understand under the hood, like how the protocol worked, how it was able to do what it did, um, and the powerful thing there is just peer-to-peer technology, of being able
Yep.
to leverage the power of the network, the massive resources that the world had built up to then create massive scale telephony network, in like in a few years, right? Like Skype went from zero to one of the biggest sort of telephony networks on the planet, um, like almost overnight.
And it was only able to do that fast because of the peer-to-peer architecture and that the fact
Exactly.
that they took a different approach.
Exactly. And that always felt to me very underrated in the 2000s.
Hmm.
So that kind of peer-to-peer tech got discovered, got really like built up in the, between 98 to 2004. And it, because a lot of the peer-to-peer community had been in like the file sharing,
Yep.
music, like all the like the problems with like the music and movie industries, peer-to-peer got a bad name. And at the same time, the cloud tech stuff was growing. So a lot of the researchers moved from peer to peer into cloud tech. And then peer to peer just kind of fell by the wayside, but it was a magically powerful technology. And it was really Bitcoin that kind of started uncovering a lot of that again and brought that thinking back. And now, we have built up a worldwide financial system that stands on its own, right? It's crazy. Like the fact that you could build an entire parallel economic system, from the ground up, now moving trillions of dollars in assets, and is now poised to like really change the traditional economic system. I was watching the Stripe, keynotes, recently from
Hmm.
like the Stripe sessions, and like they're going all in on stablecoins now,
Yep.
and enabling stablecoins as like the main routing system to be able to do a lot of like treasury management for companies and payments and all that kind of stuff. So, uh, yeah, it's just gonna kind of continue to grow from here, and that just shows the power of decentralized, internet native protocols and sort of programmability broadly, and that was like very, very inspiring for me.
It's really interesting to think of the history of kind of a pendulum swinging, decentralized, centralized, peer to peer, centralized, I guess. And it is really true that there was this wave of peer to peer technology in obviously the beginning of the internet, and then in the early 2000s that quickly got a bad name, through Napster
Yeah,
and all that stuff, and then kind of got quiet for a while. And then the cloud became the thing, and everything running through corporate centralized cloud. And it was Bitcoin that just like was a resurgence of, wait a second, there's actually new things we can do with peer to peer. And but even then, like 2011, 2012, when we got to know each other in 2014, like Bitcoin was this second wave or the next wave of peer to peer tech, but also had kind of a weird reputation and a weird
yeah.
vibe, and it has stayed that way for mostly for another 10 years after that. But I do think that's changing now, and I think the story of the internet is kind of the same thing, where it just feels like this weird toy or this weird chaotic wrongish architecture that actually turns
Yeah,
out to have these incredible properties that eventually become useful for everything, but it really takes a long time.
yeah, and it's a great analogy, right? Like the early internet, all the packet switching stuff, got built up in the 70s, 80s, and the telephony network people, looked at the packet switching stuff as totally the wrong architecture, and they're like, this is never going to work. Like, you want to do, proper circuit switching of, dedicated lines, and like that's way better, and so on. And they kind of like laughed at the internet as like bad design.
Right.
And nowadays, all of the telephony stuff now gets routed over packet switching. It's, a huge triumph. But yeah, it took like 20, 30 years for that to develop, and like for the protocols to get built out, for the all of the kind of refinement of the systems and whatnot to end up in this much more scalable, much more loosely connected set of pieces that could interop much better. Decentralization has this huge power. So I think the crypto and Web3 communities harp a lot about it to the point where the word just kind of gets thrown around and it becomes like not very useful. But I was listening to Tyler Cohen recently, and also talking about like all the Austrian economics people and a bunch of other economists over time. And one of the massive themes in economics and economic models and so on is like the degree of decentralization in decision making in systems and markets. And
Mm-hmm.
if you have decentralized structures where decision making is moved into the edges, you're just dramatically better able to respond to stimuli in the environment.
Yep.
You can respond much faster. You can calculate local solutions much better. And it's just central planning is very, very, very hard to make work at any kind of larger scale. And even if you can get central planning to kind of find some local optima, you're definitely going to make the wrong decisions for a lot of the parties in the edges. And so decentralization, even when it doesn't find the optimum, it definitely finds very good solutions broadly. And that's kind of like a much better way of aligning preferences at a wider scale in the world. And like it just applies to economics, computing systems, money systems, governance structures, all kinds of things. Right? Like the US is like a huge experiment in decentralization in itself. Right?
The way that we articulate our investment thesis at USV is looking to invest at the edge of large markets. And I think there's a lot of what you just said that's baked into our reasoning for that, which is if you can empower the edge, you can empower experimentation, discovery, and scalability, right? Versus, deciding in the middle, which is sort of like central planning in some way or another. I want to come back to this because there's also a theme in the air right now around within crypto and Web3 around kind of decentralization as it relates to like leadership. And I think there are some tensions there, and I think there are situations where trying to decentralize too fast could slow you down as opposed to speed you up. And there's a bunch of nuances in how to retain, how to move quickly and I don't know how to show up
Yeah,
the right way, like in the market.
it's a great question and huge problem set because just human organizations respond much better to hierarchical leadership. It's just humanity has been evolving for a very long time to form like bands with clear leadership structures, and most of our civilization has been oriented or organized that way. If you think of an organization that's hierarchically organized as a tree structure, then a decentralized system tends to be a forest of like where you have a bunch of different trees.
Yeah.
But if you go all the way to like really diffuse, like landscapes where every person is making their own decision at any one moment in time, you run into like extremely difficult coordination costs. This is the same, Coase theory of the firm kind of idea of like why the firm emerges in the first place in a world of kind of contractors in a sense. And I think for decentralized networks in crypto, this is a huge challenge because a lot of the communities want that leadership. Like they kind of need very visible leaders to kind of drive things, but that really pushes against decentralization. The best example right now is maybe happening around the Ethereum community, where I sort of watched Vitalik do this like really careful kind of stepping back over time to enable a lot of other participants to kind of emerge and kind of drive the different parts of Ethereum. And now the community kind of like wants somebody to just kind of like be driving the ship.
Yep.
And I'm sitting here thinking like, guys, like we achieved this like amazing success by like building the system without a leader. Like it took an enormous amount of work. Don't like throw it down the drain by like now wanting some kind of like very strong king somewhere to drive things. At the same time, certainly to drive roadmaps and drive development and so on, certainly individual leaders can get a lot of things done, right? I've been a huge admirer of lots of different great leaders in tech over time. It's just kind of amazing what a single person with a very strong level of conviction and kind of marshaling resources and orienting people can achieve in very short time scales. Um, and so it's like this it's going to be this constant tension in decentralized networks around how do you build larger scale structures that can coordinate well and evolve well, and ideally do not kind of create the need for these like individual
Right.
leaders to constantly be there.
Or maybe there are going to be emerging designs that can allow for leadership, but also allow for a lot of decentralization and decentralized decision making. Like an example that we've just been looking at recently is in the DeFi lending space, and looking at projects like Aave, which are sort of controlled by governance in sort of a central manner, versus projects like Morpho, where there's like an org that's leading it, but every they've designed it as a set of funds on the protocol that are managed independently, a little bit like the way Uniswap pools are all managed independently. So I think there's also like a really interesting design space for sort of leadership at a very low level that enables something like very wide and
Yeah.
decentralized. But let's dial it back a little bit and get back to you and your story. How would you just characterize the slow hunch that you're on in a phrase or two?
Probably the most important thing that's been true for the last 15, 20 years, and that it's kind of like the organizing principle around everything else, is that I kind of realized early on that if you want to broadly improve how the world works, um, you want to do a lot of science to discover how the universe works, and you want to kind of accelerate the pace of scientific progress, and then you want to translate the fruits of science, like all of the knowledge and ideas that you've been able to figure out, into technologies that can be diffused broadly. This means getting the technologies into products and diffusing them into society. I was, very inspired by places like Bell Labs and other kind of great labs in the 20th century, things like the Apollo program, the Manhattan Project, many other, Intel, many other companies that built great things in that period. And there was this kind of long tradition of deep research and development at scale. In the U.S., in other places in the world too, for sure, but especially the U.S. did an amazing job between the 40s and 70s, and that kind of broke down in the late part of the 20th century, and it doesn't quite exist now. And I kind of got the sense that there had been this massive slowdown in the pace of technology translation. So the science has been advancing. We've been continuing to discover all kinds of things in every single field that you look at. We're getting more and more results over time, and there are more scientists now picking at the fruits of the tree of knowledge than ever before. And the results are pretty significant. We have yet to see kind of something as fundamentally shifting as quantum mechanics, say, but there's been lots of incredible developments in every field. Um, and yet the world hasn't changed as much per year
Hmm.
or like per decade than
Hmm.
it did in the early part of the 20th century.
Hmm.
I'm not the only person to point this out. I think Tyler Cohen, Peter Thiel, others have pointed out that there's been this huge kind of global stagnation around the rate of change and the rate of progress. Um, and my answer to this comes from looking at the capital flows that go into the different stages of the pipeline. So if you think about how the process of discovering new ideas, in science, and the process of technology building in early development, and then building a business and diffusing it out into the world, that entire thing you can kind of integrate it into this kind of research and development pipeline,
Yep.
and that whole process sometimes can take up to 10, 20, even 30 years for certain technologies. And it usually, for larger things, it takes hundreds of thousands of people, potentially more, massive amounts of capital, many projects. And there's this kind of problem in the incentive landscape where, for the latter parts of the pipeline, once you have a clear business and a clear product and market, you can build companies and scale them. And we know how to do that well. And for the very early part of the pipeline, we have national funding for basic research and maybe
Yep.
philanthropy. But in the middle, there's like this huge gap where national funding agencies do not fund early development of technology translation. And it's usually way too early for VC to be able to fund things because sometimes there's just no companies yet. And that's the thing that the labs of the 20th century, Bell Labs and others, did so well. That like early development phase of technology translation, and that effectively broke down with those companies. So if you look around today, like and look at the fields that are working best in terms of translation of new discoveries into products as quickly as possible, they usually tend to have some mega corporations that are
Yep.
funding that early stage development. So think of like the advancements in semiconductors or like optics for like LCD screens or um, like yeah, all kinds of like manufacturing processes and so on. Like if you or like certain material science things where like there's a very concrete and clear set of products that are going to use that tech, and any new or nascent field that hasn't yet evolved some like big cash flow to fund the
Right.
development piece is totally dead in the water. It's like super stuck. Energy is like a famous one in this, where like fusion is super stuck. It's
Yep.
getting better now. A lot of nuclear is super stuck. There's regulatory constraints there also affect the time scale, but transportation, all kinds of things are just kind of very very stuck. New areas in bio, for example, like there's all kinds of new discoveries that don't even have like very significant regulatory hurdles. They just kind of need to do a bunch of science and early stage development, and it's pretty expensive, and it's just so hard to do it, and it's so capital intensive, and it's so the success is so uncertain that it just doesn't make sense for private capital. It's just too expensive. Like your return rate becomes negative if you invest in a lot of these things, and nation states don't fund that stage. And so like that whole like that's what I've been trying to work against in kind of like everything I'm doing across the board is figuring out incentive structures to plug that hole, or at least build one institution that can generate a huge cash flow in the private capital side, and then route it to that part to like help plug that hole and kind of accelerate R&D. And from my perspective, if we can do that well, then we can kind of reap the benefits of the tree of knowledge and reap the benefits of all of the science that we're doing, and translate that into better technology, better products, and kind of uplift society and kind of make everyone's lives better. I'm always kind of flabbergasted at like how many important results are sitting in papers that could be like saving people's lives, hundreds of millions of people's lives, um, and yeah, they're like stuck somewhere in the R&D pipeline. And if we could only crank that faster by a few years, then so many more people would survive. And like that's crazy to me that we're just kind of not organizing ourselves dramatically better.
Fundamentally, what you're describing is kind of a resource and capital problem where, the labs of the 20th century that were able to fund, deep research or core research, and the big tech companies today, it all comes from having capital and resources, right? Someone has to have the capital to fund
Yep.
this stuff through the non-economic, trough. And that has worked better or worse in different times. Part of your kind of vision and mission and mandate and goal for where you're taking Protocol Labs today is to, create an economic engine of some kind that can start to fund this or can continue to
Yeah.
fund important parts of research. Crypto is a big part of that. Tokens are a big part of that. And I want to talk about that. Maybe we could go back to 2013, 2014, when you had been out of college for a couple of years. You had worked in the professional world in a few ways, and then you had the idea for starting Protocol Labs. What did that look like? How did that come to
Yeah.
be? What was the initial thinking?
So I had kind of like this, kind of wanted to solve this large pipeline problem. I didn't
Yep.
quite know yet how, but I knew that I wanted to build an institution that could do it. And because I had been studying distributed systems and file systems and so on in the past, I had like a bunch of ideas that had been simmering in my mind for many years. Again, that were sitting in papers and not well implemented at scale. That always kind of struck me as like, wow, you could like just do way better if you can combine some of these things and craft something. And kind of like around 2013, I put a set of these together into what became IPFS,
IPFS stands for.
the Interplanetary File System, which
Right.
is it's an homage to the the internet, because the internet actually stands for the Intergalactic Network. That's like the real name.
I did not know that.
Yeah, it comes from a memo from Licklider like early on, who's like one of the main people that help organized all the resources to do the development of the internet in the early stages, and painted the vision of like, because so at the time there were all these different networks that were all kind of piecemeal and so on, and like you couldn't like interconnect things, and um, so he's like, this is ridiculous. We just need everything to talk to each other. Like we need one meta network, one like network of networks. And if we build it right, then it could extend into like the planets and the stars and like eventually be like one network for the whole galaxy. And like the early memo like just talks about like the intergalactic network. And that's the internet. It's like the birth of the internet. Like
Amazing.
it's way earlier than the web, way earlier than TCP/IP. This is like the stuff that put everything in motion to cause those things to happen.
So in that context, interplanetary file system is really a small vision, right?
Yeah, exactly,
Not even
exactly.
intergalactic. Yeah.
Yeah, exactly. I was like, like if we're gonna build the intergalactic network, at least let's get the planet stuff working right, and then eventually we can figure out like the interstellar level. Yeah, yeah, totally. Um, and also IPFS has this like nice fit to like IP, right? So like if you have the internet protocol, then
Yep.
IPFS is kind of like the file system for the internet.
Right. It
Um,
almost sounds like the Internet Protocol file system, right?
yeah, exactly,
You could read it both ways. Yep.
exactly. And that's kind of the thinking behind it, and kind of like the kind of breakthrough moment was that because I'd already been kind of working on this combination of Git and BitTorrent for trying to like do peer-to-peer distribution of data sets in lots of different ways. And I worked on a number of projects at the time doing this. But like the real breakthrough came when I sort of combined it with like some of the early file systems thinking around how do you do this securely and with public key cryptography. And then I realized that if you could expose websites in this way, then you could make the web itself operate in a peer-to-peer model and like break
Yep.
apart the client server dynamic and instead make entire web apps and websites that like move around just like files in a peer-to-peer system. And that was like a really big kind of potential. And that's when I decided, okay, great, like I have to like go build this. And at the time, I was looking at Bitcoin as well. So this is again late 2013, early 2014, and that's when I was thinking like this hash rate thing. Like this is really clever. This idea of um, releasing token emissions for a resource that you're contributing to the network, and you have a completely mathematical way of measuring how many resources you're
Yep.
contributing, and creating this like reward stream that is going to go to these resources, and moreover do that in an auction, right? Because the block reward is an auction. Because of the difficulty adjustment, the way it works is that effectively as more people bring more power into the network, you still release the same amount of tokens to that additional power, so it effectively is auctioning off
Gets
the
harder.
tokens.
Yep.
um, and that's just like an extremely clever design. And I was like, okay, you can apply the same kind of thinking to other resources. Like you should be able to do this to amassing storage. You should be able to do this for compute networks. You should be able to do this for bandwidth. You should be able to do this for like lots of different things.
Yep.
And that's where for IPFS, like the very natural complement was to kind of start with the actual storage, and that's where Filecoin came from.
Just to try and put that in the context for folks who haven't been as close to it. Well, we met you when IPFS was a thing and Filecoin wasn't really yet an idea, or it was just beginning to be an idea. But the way I've always thought about it is IPFS is a smarter design for keeping track of files and not losing them and not breaking links and all these things. So you kind of fixed some core ideas about how to keep track of files on the internet, right? That was a big unlock, but there was no incentive to get it deployed, right? And so
Yeah.
Filecoin was basically taking the idea of IPFS and saying, if we like this idea, then how can we like take the lessons from Bitcoin to actually get it deployed in physical hardware in the real world?
Yeah, exactly. And the separation is also comes from the fact that you want to put the incentive layer at a separate spot than the actual protocol for how you address things,
Mm-hmm.
because you might have many reasons to do something, right? So like I really dislike systems that bundle the incentive structure into the core design
Mm-hmm.
of the basic primitives, because it basically means that like you have to use the incentives to do some basic stuff, right? So if you have like 10 devices in your house and you want to move them around, you do not need to like have an account with money and pay yourself and reason about paying your own devices, right? And if you want to do this with your family, like you definitely don't need to like start charging your siblings for like enabling them to store some of their data on your computer, right? Like, and so you definitely want to move, you want to kind of decouple the economic incentive structures from the core protocols around like what actual computation is happening, and you want to layer these on top. And so the idea is like, you have IPFS at the bottom and then Filecoin on top as a reason for like Filecoin gives you the incentive structure for if you want to hire a cloud system to store your data, you can hire Filecoin. But you could also like not and
Right.
store it yourself, or you could have a more resource sharing type of thing. Um, and so that separation was kind of important. It's also the case that these systems tend to be large and complicated, and if you put too much into one of them, it just
Right.
kind of
Right.
it's
And
difficult
and
to
the
make
history
it
of
work.
internet protocols is sort of a layering of
Yes,
protocols and keeping each one, kind of as simple as possible.
that's one of
Right.
the beautiful things about the internet, and one of the great things that the IETF did was just kind of set this trajectory in motion of breaking apart large complicated things into clean layers of abstraction. And if at any point like you could fault any of the protocol designers in the IETF for anything, usually comes from like not decoupling certain things well enough, right? Like and even though they did a phenomenal job with so much of it, like so much of this architecture has lasted 30 to 50 years when you look at tons of these protocols, and they work really well at massive scales. It's like truly phenomenal engineering, right? Like I really wish today engineers were as thorough and disciplined about protocol design as people were there back then.
Yeah, in some ways we're in the golden age of experimenting with protocols and protocol design. And I think part of what's been so exciting to be part of that space over the last dozen years is that Bitcoin and Filecoin and Ethereum and everything that's come on top has turned a generation of folks who might have been, I don't know, app developers or infrastructure builders into kind of protocol thinkers. And so there's just been an abundance of experimentation there and a lot of learnings. Um, it's interesting that Filecoin, to me, that Filecoin was really a pioneer because I think that you designed the protocol maybe 2015 to 2016, something like that.
There was a V1 in 2014 because even before starting Protocol Labs, I already had
Okay.
a rough structure for how to do it. But then there was a bear market then with Bitcoin, and so and it had been like I initially thought that we would build Filecoin first. We would build enough of IPFS, build Filecoin, and then come back to flesh out IPFS. But what ended up happening is that because of the bear market then, a lot of the attention around crypto kind of waned, and at the same time, the early alpha of IPFS was picking up, and a lot of people were starting to use it. So then we devoted 2015 and 2016 to just fleshing out IPFS and building it up, and we put Filecoin very much into the back burner until late 2016, 2017.
Right.
And at that time, when we looked at it again, a lot of things had developed. We had learned a lot by building IPFS, and so then we kind of did a V2 of Filecoin just in paper form, like before writing anything. And that was like a much better system.
I'll never forget. I think it was our annual meeting, which we always do in the fall, where we talk to our investors. And I'm pretty sure it was the fall of 2016, where I think you might have, I can't remember if you were there. I think you might have been there,
It
where
might have
we
been,
said,
yeah.
yeah, where we said to them, we've always been buying, shares in companies, but we've been now investing in these crypto networks. Crypto networks are different. And as more of these networks start to launch and start to use tokens in interesting ways inspired by Bitcoin, we may end up holding tokens instead of, or in addition to holding, shares. And I think Filecoin was one of the very first projects where we were like, oh shit, like there might not be like a next equity funding round. There might just be
Yeah,
tokens out there. And we like prepped all of our LPs for like, we might end up holding tokens. And so that's another place where I think Filecoin was a real pioneer, was like early in like launching a token as a foundational
yeah.
element of a network, in a time with a lot of attention on it. What was that like?
Yeah, I remember in 2014, 2015, already talking to people what was going to be our business model, and I used to describe it as like, well, we'll literally make money, like we'll create money, and then we'll hold some of it. And people were like, this is crazy, like it's never going to work. I remember going to firms that are now like huge in crypto at the time that were like, this is crazy, this is never going to work. And they're like, this model's never going to take off. And a bunch of us like proved it out. Like we, and this was like, I think there were a few groups in 2013, 2012, 2013, 2014 that were like starting to do this. And then we were kind of like part of a cohort in 2016, 2017 that like
Yep.
scaled it even further. Um, and yeah, it now is like very common and very structured and so on. But it was a lot of like figuring out new ways of doing capital formation, new ways of figuring out like how do you use like how do you like model, how do you connect engineering and development teams with a token flow, because a lot of this stuff is figured out for corporations, and that took 100 years to figure out.
Yep.
And now we had to like redo that thinking in the crypto space. And in fact, I think that's maybe one of the areas that I'm most excited about in crypto is like new ways of organizing the capital flows of a crypto network to provide for their own development. A lot of the things we figured out was like this new business model, creating token networks, getting a piece of it, all of that kind of stuff. Things that we missed, and I think the broad ecosystem missed, where providing for the long-term support of these systems and the long-term fleshing out of these systems.
Right.
And that's where like I think some of the PGF, the public goods funding structures like retro PGF and other things are really good pioneering ideas, because it points at a way by which these crypto networks can fund their own development at scale. It's not just funding the emissions of the resource part of the network; it's also funding their fleshing out and development out into the future. Every few years, we kind of like solve, as a community, we solve like a major component and problem in kind of like the production of these massive resource networks.
Yep.
Right. I tend to look at these as like international global utilities. When you think about most nation states, there's a class of corporations called utilities that work on providing basic services broadly, and they usually have to do with some combination of resources that you're providing to a large community. And utilities are a major feature in everyday life. They're less shiny, because the golden era of like utility companies was like the 1880s through 1940s, and like that period was like utility companies were like all the rage.
The concept is so fundamental, but also is less exciting, and it's not, you don't think
Yeah,
of it as a, right.
it feels like a dinosaur, right? Like when people say like, oh, a utility company, it feels like the dinosaur equivalent of companies. And in reality, like you go back and look at the history of utilities, and like, man, like this was the bubble in the 20s was primarily around utility companies and like securitizing utility companies, which is like kind of like an interesting history. But anyway, like the broad point is utility companies have been incredibly successful and useful. Even Bell, like the Bell Labs, was effectively a massive global international utility. Yep. And so you can think of these crypto networks as being able to give you a broad international utility system that anyone can contribute to. And so you can work for the global utility and provide resources, or you can hire it and take its service. And you have an entire protocol and market structure for how that utility functions and how it like develops in various places and so on. And some of the stuff that we figured out early included, okay, great, how do you amass the resources in the network, and how do
Yep.
you like provide the basic service? And so we kind of like got that down. Then we figured out how do you do capital formation to fund the structure of this utility.
Yep.
And like that was kind of the token model, like the token business model, the ICOs, all other kind of structures like that. Then it was, okay, great, like how do you fund the long-term ongoing development? And like that's kind of what a lot of the community is figuring out now. How do you do decision making and road mapping and like planning? And kind of like what's going to come right after, which I think is like really needed, is how do you do good sales and product development for like the end user? When you look at most of crypto today, most crypto groups do not have good product chops. Like they don't really know how to make something people actually want. And it just comes from both the complexity in building these systems, draining all their attention in like just getting them built up in the first place, And then second, the fact that the industry just has a low bar for quality in terms of products, and so people are able to like ship a lot of things that just aren't that good when you look at them as great, and you compare them to maybe the best in class products in the world. And so I think like that's a major next phase for the crypto industry. Is like we have to evolve excellent product sense. We have to compete, apples to apples with the best possible utilities or services around the world, the best, technology and product companies in the world, and we have to figure out how do you do sales and distribution in this kind of decentralized context. For some of these networks, the sales process is very difficult because you have to like, if you want to sell to a large enterprise or a government or something like that, there's a lot of like long-term relationship building and
Yep.
communications, and like they want to talk to people. They're not just going to look at a protocol and that's it. And so these networks have to evolve these decentralized structures to provide these sales processes. And I think like eventually we'll figure that out. And so we're like building all the pieces of like, how do you build these massive scale services globally? And eventually like we'll have something that I think is going to be dramatically more powerful than the existing corporate structures.
Yeah.
I don't think it is yet, but I think it will be relatively
Well,
soon.
and it's so interesting to think about. What do you mean by utilities? And most people don't think about protocols as quasi utilities, right? But the workhorse protocols of the internet, are these global open utility like infrastructure protocols, IP and SMTP and HTTP, and there are these universal standards that the whole world coalesces around, and because everybody uses the same thing, it helps everything work together. And there are these sort of digital infrastructure utility rails, not so dissimilar from power and telecom and water and sewer, but they're the digital version. And things like Bitcoin and Filecoin and Helium and Uniswap, like we're the crypto industry is essentially the digital utilities industry, right?
Yes.
And trying to create universal public goods that everything can
Yes.
ride on top of to maximize efficiency and usefulness. And to your point, it's there's all these phases, right? So it's the bootstrapping phase, it's the deployment phase, it's all like the maintenance phase. And I think as an industry, we're only a dozen years into thinking about crypto powered protocols and utilities, and so each of those phases is still getting discovered.
Yeah, and I think all of us wish that it was going faster and that we would have figured it out from the get go. Um, but sometimes it's useful to like look back in history and see just how long some of these processes take.
Yep.
Like the cloud took 25 to 30 years to build out. Like people don't talk about this today, but the cloud is like from early 90s. Like people were already talking about it, figuring out some of the structures. This is long before Amazon existed,
Yep.
long before Google was doing stuff. It wasn't called the cloud yet, but like a lot of the underlying frameworks were being built then, and the structures and like the reasoning and like the important papers talking about like resource utilization and multiprocessing and all that kind of stuff was starting to be put in place. And then even Amazon itself and Google took from like the early 2000s all the way into like early 2010s before like the cloud was starting to be taken seriously.
Yep.
And sure, now like everything is in the cloud, but it took like 20 years for those companies to really do it.
Yeah,
But
same story for AI, same story for crypto, right? And so if you think of
yeah,
AI, like the cloud being a 40-year project and AI also being a 40 or 50-year project,
yep,
this set of protocols that we call crypto and assets is really only a 10-year project right now. And so there's always, I think, a frustration in the air that, why is it not moving faster? When's it not going to become more mainstream? But like, I think your point is exactly right, that there's a lot to figure out, and the more complex, distributed, open the system is, the longer time that takes.
yeah. I do think, I hope that AI systems will help us do this a lot faster.
Mm-hmm.
I really think we're in the cusp of a just major global change around how really everything works. And one of the big things that's going to start happening is tons of software is just going to get built by entirely autonomous systems, and AI systems will use pieces of software and services. So one of the things that how we're thinking about this in the Filecoin community is to start reshaping Filecoin to be good for and appealing to AI
Sure.
systems. We want
Yep.
it, we like, because pretty soon developer experience is going to be like, how do you tune your system to appeal better more to AIs than humans? It's kind of like a crazy thought right now, but like already 30% of software is being written by AI systems. That's going to be 90% in not very long. And if you can create an environment that's like really good for these autonomous agents, then that'll like be the way to like diffuse into lots of things. Um, and so I do hope that like a lot of these things that we're talking about can get figured out by AI systems. One of the key points here is like we have to figure out how to enable these intelligent systems to participate in the design of the platforms themselves. Meaning like how do you enable AI systems with like good ideas for how to improve them, to file the equivalent upgrade proposals, improvement
Yep.
proposals, and
Huh.
write the software for it and like patch the protocol and like improve it.
So we had a call a couple weeks ago at USV with Vinod Khosla, who joined us for an hour just to like riff on what's going on in the world. And he's obviously a giga brain and an incredible investor, and sees the past and the future deeply. And he said something that stood out to me, which was that um, the most important area for applied AI right now is actually AI research. So having AIs do the AI research, and it's which is also a little bit of a mind exploding concept, very similar to what you're saying, is that the humans have been doing the hard work of trying to design protocols and governance and everything else to make this stuff work. But pretty soon we're going to be sharing that task.
Yep. Yeah, totally. And I fully agree with Vinod on that. Like, the kind of like intelligence explosion gets unlocked when you have AI researchers able to develop better algorithms and better chipsets and so on. And like we're very close to that. I think like most predictions today are in that we should hit that late 26 or like 27. And so that's kind of like what most of the big labs are orienting around. It could happen faster, but it could happen later. But that's kind of where the bulk of the probability distribution is. It's a good report called AI 2027 that kind of like goes a little bit
Yep.
into this. How you combine these results with crypto is like super exciting because it means not only do you have a dramatically better way of leveling up all this infrastructure, but you also have a whole new category of users
Right.
for whom these systems are better than the traditional systems, right? Like when you think about moving money and you think about like the traditional financial structure and you think about crypto, an AI model will like prefer to move around crypto. It's like much more native, programmable, and so on. And so like we really stand to like quickly rebuild a bunch of infrastructure globally if we can harness this kind of like coupling with AI systems. Yeah.
I'd like to get your take on more on how these things fit together, because I think there's something profound here. So if you think of crypto as languages for computers to talk to one another, and digitally native protocols and systems, and then the hard part of crypto has always been, how does that bridge out to the real world, the legal world, where humans are in meat space. Um, AI systems are kind of the same way, right? It's about bridging language with computers. Actually, that's a huge one that we've unlocked in the last few years.
Mm-hmm.
And from there, I think you've got sort of crypto and AI as two sides of the same coin, which is moving towards something much more digitally native, much more compute native, where all kinds of things are going to happen more at the speed of computers and less at the speed of humans. How do you think about that? Like,
Yeah.
where do you think that goes?
Cryptography gives us the ability to build rights systems on top of basic communication systems, right? So basic communication systems just means how do you move around messages, and cryptography lets you build structures to give you privacy, to give you security, to give you assets,
Ownership,
currencies,
right?
ownership, all of this kind of stuff. And so like cryptography is like a new basis for a new legal system. And so I look at blockchains as like little economies in a box, like very rudimentary economies in a box
Hmm.
that have their own, smart contracts is a good word for that reason. It's like designed as a, concrete contract structure. I think like the, smart contract sticklers would say hey, smart contracts today are like more APIs than real contracts, and you don't yet have courts to adjudicate them, and so on. We've seen a few experiments in that direction, but none of them have quite really worked. But I do think that this is like very solvable now. Like you could actually write proper contracts that when there's like a dispute around them, they could like call out to an LLM to adjudicate them, and you
Yep.
could do this today in blockchains. And this, so from my perspective, this is like a huge upgrade to our fundamental economies and our fundamental legal systems. We just need to kind of like close the gap into actually build it somewhere. And instead of kind of like bridging back to kind of like the real world and this like bizarre crypto world, instead, what I want to do is like find an actual jurisdiction somewhere that is okay treating the crypto native ledger, like the actual
Right.
blockchain, the records there as the ground truth.
Yep.
Those are the contracts. That is a corporate registry. That's the assets. That's the ownership. And there's a lot of them that are actually much more excited about doing that today than 5 years ago, especially because of AI. Because the moment that you do this, you enable fully digitally native corporations
Yep.
and fully digitally native agents that can like now transact in the world. Like they can have different kinds of rights. They can like interact with each other. They can hire each other. They can hire people. Like all kinds of things can then kind of emerge out of that. And you don't have to like chase around humans for like a wet signature and a piece of paper somewhere. Like this is crazy. Like why are we still doing this? Right? Like this is wild. Like um, and so like I think that that's about to happen probably this year, maybe next year. Could be a little bit later, but like that's kind of like where my guesses are. And the thing that happens soon after is that AI systems will effectively come into the world and acquire a version of peoplehood through corporations. I think it's very difficult for the world today to
Right.
accept the idea of treating these models as like another like type of people yet. Like I
Flesh
think like
human.
that idea is very
Yeah.
controversial.
Mm-hmm.
Um, I think it shouldn't be, but like because I don't know, like people should be more humble. But that's going to be a very difficult question of like the idea of like how do you create rights in our civilization for AI systems. But I think the way it's going to happen, because life tends to follow the path of least resistance, is that because we already have rights for corporations, and corporations already have a version of peoplehood, AI systems are just going to inhabit the corporate structure. So we will probably see corporations that themselves are basically a single agent or a little collection of agents that will have peoplehood and personhood and rights. And we will have AI models now starting to have like real weight in the world through corporations, just because that infrastructure is already in place. Where this can really take off is in this combination of crypto and AI and corporate systems. Like if we can kind of create a good jurisdiction in a box that is actually recognized globally, you can do this. And at the same time, like this opens the door to massive risks where like
Yep.
because that's how you get rogue optimizers and all kinds of
Yep.
problems. And this is also where crypto gives you this amazing edge, because the whole paradigm is to very cleanly and clearly create verifiable structures for the transactions. So
Right.
you can define a policy space of what are acceptable transactions and what are not acceptable transactions. And you can bake in like the court process of really deciding what's in the best interest of civilization at the whole into the transactional process itself.
Yep.
So even before a transaction takes place, you could very quickly assess what are the impacts of the transaction going to be, roughly estimate it, and decide whether or not the transaction clears. And like that's a total paradigm shift, right? Like this is something that like the world today cannot do in like the traditional space because you want to enable quick transactions. But when you're operating at light speed, like you can totally do this.
If you have AI systems that are, let's call it crypto native, right, that are born from the cryptography, governance, and controls of blockchains and crypto networks, um, and if that becomes their jurisdiction, let's say, and you have contracts and ownership and controls that are built in at the smart contract layer, um, in the best possible version of the world, these AI systems are bound by that jurisdiction, right? And you can stop transactions, you can shut things off, you can in a native way, versus
Yes.
having to kind of bridge into the legal world and back, and then also you get this traceability, verifiability, clear ownership record, clear control plane. So that excites me because it's an optimistic and positive vision for how these two things fit together, and in some way, you know, could quell some fears about AIs getting out of control and AIs on crypto getting out of control. Because you also start thinking about AIs with crypto wallets that can spend and develop
Yeah,
build up asset balances and amass like power, like real power. That's scary.
exactly. So 100%, and that's exactly what I meant by like these rogue optimizers. Like the rogue optimizer idea is like you have like a very straightforward AI system that is trying to optimize for some stupid thing, like the paperclip maximizer is like the
Yep,
best
sure.
example.
Yep.
And then like they amass massive resources and like tile the world in paperclips. And so like um, and you could totally see a path by which, like, if you enable a super intelligence to acquire resources through financial systems, crypto or otherwise, like you could end up accidentally in that landscape fairly quickly. And so you want to be able to be really careful in how we go there. One of the like, really great causes for optimism on this that I think is very underappreciated right now is something that is kind of a consequence of the architecture we built these models in, meaning the way that like ML models are being built today, like these massive deep learning transformer structures, um, you basically expend this massive set of resources initially to train them, and then you end up with like a very small model, like terabyte ish of parameters that you then run in like single computers at a time, like
Mm-hmm.
single graphics cards, or like now they're really AI cards, but like single NVIDIA chipsets can like run one model. And what that paradigm gives you millions of agents, right? Like very quickly that are all at the top tier level of intelligence. So it is not the traditional sci-fi model of you're going to build one single super intelligence that like knows everything and is like is now humanity against like the one evil AI sort of thing,
Mm-hmm.
but it's instead you boot up millions of very super intelligences at once, and you instantly have a civilization. And what that means is that all of these agents are optimizing for their own good, which means that they instantly need laws. Like they instantly need a way of
Right.
relating with each other, and they're instantly in mutual conflict. And that's a very optimistic thing because it means that the underlying structures of society and rights and like freedoms is like the same set of things that these agents are going to want from each other, let alone from humanity. And so it's like a very optimistic landscape. And the person that pointed this out to me, it's another gigabrain, Mark Miller, who's been like pioneered all the smart contracts things in like the 70s and 80s, like way before like modern crypto stuff. And he basically like pointed out that like we're kind of headed in that direction where like AI systems are gonna be in like this civilizational landscape, the same as us,
Mm.
and we have like a pretty optimistic possible set of futures here. And I do think that like if we can kind of untangle this and explore these ideas, and maybe start creating like a path to coexistence and like again people like rights for these AI models before they get extremely super intelligent, and we move from like the you know Einstein in a slave environment trying to make Ghiblis every day, right? Like that kind of like t- bad situation that we're currently in, into here's a path by which you like are members of the
Oh
of
wow.
society. That could be like a super optimistic path to success together, right? Like, and I think like that's something that like crypto suddenly has a major role to play in, and could end up being globally important in the near future. And so yeah. By the way, if folks listening to this want to work on this, like reach out to me because like I'm literally like trying to figure out like how to do this right.
It's an enormous idea, and it to me it just makes sense, right? Like if blockchains are in some ways like the digitally native governance and ownership layer for the planet, um, ideally we want AIs living on them, because that's sort of the jurisdiction we're moving in. We may be moving into. How does that inform like where you're trying to deploy your efforts today with Protocol Labs as it relates to which areas of core research are the most important,
Yeah.
and where you want to focus?
So the way we organize this in PL today is that we have a set of focus areas, and though we're interested in much more, we like concentrate on these focus areas because that's where we have critical mass of effort, and we have a number of companies and people working in each of the focus areas. The first one is around just basic crypto and Web3 infrastructure. This is where we started things like IPFS
Mm-hmm.
and Filecoin, Ethereum, Solana, all of that sort of stuff. The second is also in crypto or related to crypto, but it's about upgrading economies and governance systems. So this is like
Yep.
all the public goods funding space, DeSci, some of the deep end networks that are more like in the real world, like Glow. Then some aspects of DeFi that are like, again, thinking about like banking the unbanked and diffusing stable coins to people in like hyperinflating currencies and like all of that kind of stuff. And then the third focus area is around AI and robotics. This is like a very targeted focus area where um, we and our network have like an important role to play. So some of the stuff that we were discussing now around like this kind of like AI jurisdiction sort of thing could be it, or decentralized networks for training models. So like this would be Prime Intellect and Jensen and like that
Yep.
type of network. Or surprisingly, deep networks in AI are going to be like a significant thing.
Yep.
With
Agree.
robot and robotics and others. And so like kind of this AI robotics area where we can have something important to play, or it could be like around alignment research or things, these kinds of questions about like how do we steer this to be a very successful outcome for everybody. And then the last focus area which is new this year is around neurotech, and that comes from this thinking around hey, as we build superintelligence, humanity can really fall behind if we don't kind of speed up our own integration into the computing environment. And so that means we need brain-computer interfaces and eventually whole brain emulation in some time frame. And ideally, we want it as fast as we can, because the timeline here is like we're gonna get ASI way before we get these other things, and that sets up this like problem between oh whoops, we created a different species, and like what happens to humanity. Like that conflict is entirely around making. um and so I think like if we can accelerate neurotech, then humanity and these new digital beings that we're creating like might end up being like the same species in the long term. And that's where kind of neurotech kind of fits in.
Can I ask you one question about that? At the very beginning, you were saying how the internet was inspiring to you because all of a sudden the world got a lot smaller. And I remember that feeling. I grew up in the 80s and 90s, and the internet to me felt like this massive window into the world, right? And now here we are 25, 30 years later. Um, I think our brains can barely handle, the internet and having all the world's news rain down on us, constantly. And so I think there's a human limitation to how much connectedness we can handle. And so just thinking about, neuro, brain interfaces to AI, like, um, that feels very exciting and also like it could be wholly overwhelming for human brains. And how do you think about that?
I think we are alive in a very weird time frame. This is the moment where um, biological species kind of discovered computing in the digital species realm.
Yep.
And so we're going through like this upgrade process. And it's similar in scale at like, the discovery by life of pluricellular organisms, or like eukaryotes, or the first like intelligent systems, or the first like beings with language. Like it's kind of like that level of a transition.
Yep.
And so we really should be thinking about this at the scale of like, oh wow, how do we kind of like augment ourselves to keep up with that trajectory, the same way that like our ancestors got augmented through evolution over like millions of years. It's just like now it can happen over tens to hundreds of years as opposed to millions of years, right? Like the moment that you can actually like use the science and technology to do these kinds of upgrades, you can do all of this very quickly, right? Like the stuff that humanity does today, like we perform miracles relative to like what animals hundreds of millions of years ago would have thought, right?
Even 200 years ago.
Yeah, even people 200 years ago like would look around and like, wow, this is like miraculous kind of environment that you live in. And so like all of this is like very possible. Like it's not forbidden by the laws of physics. It's just a matter of like doing it and figuring out how to do it well and like well for everybody and so on. in this trajectory of like part of like this life tree that we're in, this is kind of like that level of moment, like the significant life phase transition. Um, and if we're not careful, like we can just become one of the additional like extinct species in the old tree of life chopping block, which most species that have ever evolved have gone extinct. But if we are careful and we do it right, then we're sort of part of like this new form of life that can like persist into the long term future. Like that's a totally different landscape to be in, and I think it's like a yeah, again, bizarre moment to be alive in. That's kind of like the cards we were dealt, and kind of like where we are. And it's pretty exciting. Like I think it's certainly like way cooler than life 1,000 years ago or like 2,000 years ago.
I think that is the perfect thought to conclude on. The idea that we are in the midst of evolving into a different form of life, potentially beyond the humanity that
Yeah,
we've known for the last couple thousand years. That's a big idea. I didn't think we were going to get there today, but here we are.
yeah, yeah. It's like it's in the air, so it's happening.
Juan, thank you so much for coming on today. This is so much fun. It's always a great pleasure to talk to you and to dig into where your thoughts are taking you and where your work is taking you. And again, it's been so much of a pleasure to work with you over the last dozen years on this, and hopefully for the next dozen too.
Yeah, thank you so much. Thanks for having me. It was a blast.